That's good.
Cool. All right. Okay, I'll go ahead and get started. I thought maybe the SUSE guys would show up, but they're not here, so we'll go ahead and get started. Let me share my screen so I can show everybody what I did since the last meeting. Okay. Can you guys see my screen?
Yeah.
All right, perfect. So pretty much the only thing that I have done since the last meeting is, last meeting we got the Salt SSH Python 3 SEP merged in. And so what I did was I created issues surrounding that SEP. I tried to break it down into issues that could be tackled in smaller steps. And so what I was just going to tell anybody is if you do have any interest or any information as to how to help tackle these steps, please just comment on the issue because I don't think we can assign them out due to GitHub's permissions. And we'll just, if you just say a note that, hey, I'm gonna work on this, then we'll make sure nobody else works on that. And then also just a reminder that these are the other issues that like just bugs within Salt SSH that we also want to tackle for this sodium release. And those are in, the link to that is in the community repo for the meeting details in the first meeting that we had. And I'll include them in the meeting details for this one as well. So that's kind of my update for now. So I don't know if you have anything to share, Tom.
Yeah, sure. I mean, I can definitely share things. Since we've got time, I'll take about 10 or 15 minutes, and I'll actually, barring any objections, I'll do a quick walkthrough on where I'm at with Heist. And again, it's the main problem, to my general embarrassment, is it always comes down to time. Okay. And we've got mostly an internal crew, and our good friend Tommy Chong is with us. So let me share my K-develop screen here and walk through where we are with the Heist code and talk very briefly about the challenges that I'm running into. Or I shouldn't say challenges as much as this is how far I've gotten. All right, so I think I walked through some of this last time, and we've walked through POP already. So if we look at the conf.py, there are a lot of additional options that will need to go in here to support all the different optionality we have when communicating over SSH. Just for the record, I know that needs to get added in. Let's see, structurally, I'm really liking where it's at this point. I mentioned last time that there was a bug in POP with dynamic names. I got that fixed. So that, you know, they work now. It was actually really interesting. The problem is that POP was loading the dynamic names under the same namespace inside of Python's modules. And so what would happen is that this is really interesting. When you dive into the Python import system, it's really not that complicated under the hood, which makes it kind of cool. I mean, that's the way to play ball, make things pretty simple. And so every time you load a module, right, it's got a namespace under sys.modules. And then all of the objects on that module are loaded into the namespace under sys.modules. So that means that if you import two things and give them the same module name, then they'll overlap. And so there was a problem with dynamic names inside of POP where it wasn't properly allocating a full module name, and so they were overlaying on top of each other. which created comedic results. We'll just put it that way. Very confusing comedic results. But anyway, got that fixed. And then just as a quick refresher here, Heist is broken up into rosters, which you're familiar with, targets, which you're familiar with, but then managers and tunnels. And so we come back to the tunnel interface here. And I've got all of these working very nicely. So all of the core aspects of creating tunnel connections inside of Heist currently work. Connecting to remote SSH systems, as well as sending and retrieving files, executing commands, and then creating the necessary tunnels. So it's all in there. And so really one of the things that I think I should say at this point is that I haven't posted this code publicly yet, primarily because I wanted to make sure that I was done with really that heavy prototyping phase, right? Because I really hate it when I post code publicly and then revamp the whole darn thing 5 times, right? Until at least we've got a good foundation going. But I think we're there. There, or at least extremely close to there. So the slick thing here is async SSH makes our lives so easy. But of course, tunnels are pluggable. So if we wanted to, somebody would be more than welcome to implement these interfaces using a shell out or Paramiko or whatever manner of self-inflicted wounds they'd like to incur while dealing with SSH. And then we've got up here in the manager interface. So, oh, that's the main Heist. Here we go, manager. So since this is primarily intended not to be just a, hey, we're tunneling salt, but the real view that I see here, and especially the more that I've played around with this, especially over the last month, again, I haven't made a ton of progress, just fixed a few little things. But I've gotten a better kind of vision of an idea of what this could look like. Because one of the challenges that we have really with anything inside of networking is what to do with timeouts, what to do with remote systems that drop off. Because you're always relying on either one side of the exchange, right, to be behaving a certain way. And I realized that if we're using this tunneling system, you could put a lot of stuff, right, of course, over these tunnels. But the entire software stack that's being deployed to remote systems could be cleanly managed from a centralized location as well. And so what we end up with is the ability over Heist to actually create a significantly more resilient minion. Because if we send that minion out over Heist, then Heist should in the future be able to also validate that that minion is running independently because it has its own still SSH channeled connection. And so subsequently, you'd be able to, from a centralized location, not only get continuous presence information about those minions, but you also have full control over their management. And so you not only get updating and everything for free, and you don't have to manage minions anymore because the Heist pipeline would be able to do it for you. Okay, so inside of the manager, what we're looking at here is the run function is going to initiate a coroutine, which is going to manage the single tunneled connection to this remote system. We need to generate the configuration, which is going to be used by the minion, and then we call this, and then we have this single function, which again is incredibly straightforward. So what we're doing in here is that we've got a configured artifacts directory. In this current incarnation, the artifacts directory is looking for a PEX build of the salt minion. Still need to figure out the best way to deploy the minion. I'm still of the mind that it would make sense for us to fully manage Python and the minion through these channels. But anyway, at this point, I'm just using a PEX one because it's easy to, make it work. My remote run directory is still static. That needs to be fixed, of course, so that it is a dynamic remote run directory, which is generated based on attributes of the target system. We make the configuration. We create a random connection name. And we get the tunnel information from the target configuration. Let's see. And then we create the actual connection right here. There is going to need to be a little more massaging on the tunnel side so that we can account for more types of authentication, of course. But the hard stuff is built into async SSH, so I'm not losing sleep over that. Next, now that we've got a connection, we're able to execute commands over it, and so we create the run directory, nice and safe with a -p there. And again, we are going to need to augment this to do a quick remote check over this run command to see what type of system it is, if it's Windows, for instance. So that will need to be accounted for. And then we copy the config over, we copy the salt minion over, we create tunnels. And so in this case, what we're doing with the tunnels is that we're creating a tunnel to localhost 44505, which channels back to the system we're calling from, 4505, and then 44506 on the remote system to 4506 on the local system. And so then that tunnel is up and running. And then the next thing to do, which I've commented out because this is where I'm at and running into a few hiccups, is that we actually invoke the minion on the remote system. And so in this instance, again, we're just doing tunnel command and then executing the minion with the configuration, of course, that we put across the line that tells it to connect to the localhost 4505, 4506 for the pub and ret ports. And then that command currently stays open, so I don't need the async IO sleep. That is, again, part of just some debugging I'm trying to work through. So, I mean, that's where it's at. So that means that the major liabilities to get the baseline functionality are things like stand up a master. The other problem that I've got is that this minion is starting up. This minion is trying to connect to localhost 4505 and 450, or localhost 44505. I have validated that localhost 44505 is tunneling back up to the salt master. But for whatever reason, when the minion tries to connect, it fails to connect. And so that's the last point that I was at just a couple days ago. And let's see. And so it's really odd because I can set up this tunnel and set up a Python server and client on either side of the tunnel, and it works, and they talk. But for whatever reason, Salt is not connecting. And so I need to, I haven't TCP dumped that connection yet. You know, that's just, I hit that on Monday. So that is where I'm at. But yeah, we need to be able to optionally have the minions, sorry, a master get ephemerally created when Heist is executed. Need the ability to have a little more like keep alive logic in here, and the ability to pass through more SSH options. Again, the nice thing about using async SSH is that it's got full support for every possible way that you can log into a remote SSH system. And so really, I just need to be able to make sure that all that information gets loaded into this target object up here and successfully gets ingested inside of that create function for async SSH. So honestly, it shouldn't be difficult. And then beyond that, it comes right back into deciding what is the best way to create a build of the minion and the best way to distribute builds of Python, which I'm still leaning on, right? Distributing builds of Python, which are built on some really old systems so that they work forward, you know, build up Python 3.7. And I think it would make more sense for us to, the more I think about it, the more I think it would make more sense for us to build a separate Python and Salt deployment. I like the whole idea of using PEX, but of course there's plenty of debate that we can issue there. But I like the idea of separating them out because, again, the premise here isn't just to maintain remote connections for Salt. The premise here is that we can create tunnels of any arbitrary application to do whatever we want on a remote system. And therefore, having a service which is providing Python makes sense because subsequently we would want to be able to have services that would provide other programming languages, preferably ones that are in wide use. So we don't need to cover Perl. Now, sorry, that was a joke. Okay, Megan laughed. Okay, I've accomplished cracking a joke. Yeah, any questions, comments, arguments, rebuttals?
So yeah, I'm kind of just trying to understand this. So essentially, it's going to run just like a minion does, correct? So it's going to be we're running an actual minion process.
It is literally a minion which is connected to a master. So if you've got a master that has standard deployed minions, you can run Heist. And in that Heist execution, you, over SSH, connect tons of arbitrary minions to a Salt master.
Awesome. So one of the problems with SSH right now is, you know, we fix something on Salt side, but it doesn't work on the SSH side. This essentially eliminates that problem. So this is awesome.
Completely eliminates that. It eliminates all the hardball wackiness problems.
Right.
Because we fundamentally simplify the approach.
Yeah, this is great. Oh, sorry, go ahead.
I was just going to say, and then beyond that, my thinking is that once we've got Heist up and running, that we'd make another project which would wrap Heist or call Heist, or more succinctly would app merge Heist, Poppy style. And then that application would be able to function like Salt SSH, where the entire stack is ephemeral, right? Because Heist is going to be running the assumption that, yeah, you've got a Salt minion up and running, and I'm going to run a Heist command, which is going to maintain SSH tunnels into an active Salt master, right? And then we could create, like I'm saying, that high-level command that behaves more like Salt SSH. So that high-level system would be the thing that would then start a Salt master ephemerally and fire everything else up, yada, yada, yada. So that you would run it in a single pass. And then the interesting thing here is that I look at this, and this single pass system that would come after Heist and use Heist would be a little slower to start up, probably less than 5 minions. 5 to 10 minions connections, then Salt SSH, but of course, beyond that, it should get significantly faster.
Awesome. And then just one other question. This is probably just you debugging, but I noticed it says Python 2 there.
Oh yeah, that's totally me debugging because I've got this PEX build from JJ from eBay because he's awesome.
Nice.
And he put it together a while ago, and so it uses Python 2.
Okay.
I need to change his script.
Okay, just curious. Thanks.
That's just, yeah, that's me being lazy. The actual artifact would definitely be Python 3. No
Right.
questions asked.
Yeah, you mentioned the Python 3 building out the Python 3 binary. So that is one of the steps that we're going to be doing for Salt SSH as well. Are you planning on just use whatever we end up doing there to use that same binary?
Definitely, that should be a unified effort.
Cool.
Yeah. Wow. Yes.
Yeah, that'll be at least my limited understanding of building packages. That task might take a while to figure out the right way to do it.
Yeah. I mean, I've played around with it a bit. I mean, you can build a static Python, but and this is kind of where I'm leaning because you can build a static instance of Python, but then you still have a ton of files strewn all over the place, right?
Mm-hmm.
And and so we would still need to deploy that Python and then untar it on the remote system. And we'd need to be able to version and maintain over Heist, so that Heist would be able to totally dynamically always lay down a new version, right? So now that I'm saying it, like if we get a good old I mean, we should be able to just make it a tarball from a standard classic static Python build, and then untar it on the remote system. I mean, I wish that there was a way to, you know, kind of do it the way Nuitka does it. And you know, there might be. Maybe I should give that a shot. So, are you familiar with Nuitka?
No.
So you are familiar with, hey, you can build Python statically.
Yeah, I was able to do it, but it took me a while to figure it out. Just use somebody's script.
But there's a system out there called Nuitka. And what Nuitka does is it allows you to build a Python script entirely into a single binary, including Python in that single binary.
Okay.
And I wonder if it would be possible, right, to use Nuitka to create that magic single Python binary. Because they go through and they compile all of the .py files so they transpile them into C++. It's a little different, right? Usually people transpile to C, but who am I to judge if it works? Anyway, they transpile to C++ and then compile those down, and then statically link them to a single binary. So Nuitka's pretty slick stuff. I'm a fan. I've never gotten it to work quite the way I wanted to, but it's cool.
How do you spell that? I want to look into it.
Nuitka, I think. And so it might be as simple as just make it, because I've struggled to find a Nuitka build that'll just do Python. But so it might make sense to just make a tiny little Python file that imports, you know, sys and just forward sys.argv to an exec, right? Or something like that.
Yeah.
So, yeah, so that might be another option. And again, Nuitka makes that crazy easy, and it's very, very fast as far as the build is concerned.
Is the idea for Heist to always use that binary or use Python 3 if it is on the target host?
I would say that should be up for debate. I mean, my thinking would actually be that it would always use the binary. I'm just leaning more in that direction, just because at that point we're saying that this overall connection is completely ephemeral.
Yeah.
I mean that slows things down a bit. That changes our target download from 12 megs for the pecs of the salt minion, up to many more megs,
Right. Yeah.
like maybe 50. But we would definitely cache the instance of Python on the remote system, right?
It would just be the first copy that we do.
Yeah. And we just need to make sure that we've got a nice, reliable mechanism for caching this stuff on these remote systems, which is, caching is so easy, right? Especially cache expiration. How hard can it be? But we've actually resolved a lot of that from a Salt SSH perspective anyway, right? I mean, it does a pretty darn good job of caching stuff.
Yeah.
For this particular use case. So there's a lot that we can learn from there. But yeah, that's where I'm at. I think this code is to the point where I can open source it. So I'll probably throw up an open sourced repo of this.
Awesome. I'm excited to play around with it.
Okay. All right. Anything else I can do for anyone?
I just had a random question about the tunnel you're connecting. And it just I haven't fully thought out this thought yet, but right now you're tunneling 4505 and 4506 to or reverse that 44505 and 44506 to the subsequent ports. Would there ever be a scenario where someone would have using Heist multiple tunnels where we would want that either configurable or just like random ports?
Oh, definitely. So that's definitely a refinement that I want to get in here. So right now I'm just statically assigning these ports because I'm being lazy, right? Because I'm still in prototype land.
Yeah.
But making the config is a pretty standard Python format there, and there's no reason why I can't pass, some quargs to make config. So yeah, so the elegant thing to do here, instead of the Tom was sloppy thing to do here, but it's again easy extension, is that the make config option could take quargs, and then those quargs would be extrapolated dynamically into the complete config. So the config, instead of it, being a static string up here, we would completely dynamically create the config down here and make config by iterating over all of the arguments that are passed. And then that would allow us right here in the single function to randomly generate those target ports from a range that we would expect to be available on that minion, which again, is there's lots of target or random port ranges that you go after, and then we're good.
Another random question I just thought of that just popped into my head. How would this work with like if someone was using multi-master?
It's a very solid question. I'm embarrassed to say I haven't considered that. I think it would make a lot of sense to be able to add multi-master into the config. Now, the challenge, of course, is that at that point we're separating some concerns a little bit, right? Because we're saying that we've got a single management connection over SSH, which is managing the existence of the minion on the remote system, right? But then we would just make it so that we could modify the config so that that minion on the remote system could actively connect to arbitrary masters instead of assuming that it's always being back channeled. Does that make sense?
Yeah, I'm just wondering if it would be as like a simple as just having, like, say you have one minion with the 1 minion process or 1 minion host. From that minion host, you just have multiple tunnels. Like say you have 2 masters, or you have 2 tunnels, 2 different ports, and it's acting like it's connecting to 2 masters because it is. It's just going over 2 different tunnels.
So, okay, so yeah, I think there's a couple of ways that we could kind of skin this cat. One would be that you would have an initiator using Heist, and then the minion you create doesn't SSH tunnel to the masters. You use Heist as a stand-up mechanism that can be maintaining those systems arbitrarily, but then the minions connect naturally to masters. Okay. So that would be option A. Option B would be something along the lines of you would be running Heist on each of the multi-masters. And so when you run Heist on each multi-master, we would allow it so that it would somehow, through a configuration, detect that I'm connecting to a minion that's already running and I'm just going to extend its config and restart the thing, right? I can see cases for either of those, right? Yeah, but even if we take the back tunneling out with the first option that I'm kind of throwing out there, even if we took the back tunneling out of the system, that in and of itself has frankly significant value, because then you're still able to have a single system which is decoupled from your overall management stack, that is able to maintain the long-term update and management of all of those minions, right? Which allows you to have a complete side channel for maintaining your minion infrastructure, which in and of itself is way better even than us making bootstrapping easier, right? Because yeah, then those connections could be maintained or not maintained. But that's kind of similar to just using Salt SSH right now to create a roster that goes out and runs a command that, stands up a bunch of minions. But this system would potentially make it easier because we tie directly into that whole ephemeral caching system to make the minions even more ephemeral. That's what I'm saying makes sense. Am I just gibberish at this point?
No, that makes sense. It makes total sense. Yeah, I'm also wondering, like, I think we had talked about this briefly when the whole team was out in Utah. Like, I'm curious to see how this stuff can be used for and improve all of the SSH proxy minions that we currently have.
Yeah, no, that's also a good point. I mean, especially just async SSH. Like, oh my gosh, it's so much nicer. I gotta buy that guy a cake or something. If I ever meet that guy, I need to buy him many drinks or whatever he wants. Okay. Any other questions, comments, arguments, rebuttals? All right.
Alrighty, I guess we'll end it here then. Thanks for showing that off, Tom.
Okay. Sorry, I was a few minutes late for this one.
Oh, you're good. I'm sure it's well deserved. Those conferences can be tiring. So, all right, we'll see you guys next meeting then.
Okay, sounds good. Thanks.